On June 13th, 2026, at 5:09 in the morning, the ground in Yellowstone's Biscuit Basin tore itself open. Not with fire, not with lava, but with steam. A sudden, violent hydrothermal explosion ripped through the earth just north of Black Diamond Pool, hurling rock and mud into the pre-dawn air. Within days, the raw wound had collapsed into a 61-foot-long fissure. A new boiling pool, hissing at 90 degrees Celsius, spitting jets of scalding water 30 feet toward the sky. This is the real, immediate danger of Yellowstone. Not the mythic supervolcano of headlines, but the plumbing. The vast, pressurized, unpredictable network of superheated water that runs just beneath the surface. For decades, we have been staring at the volcano, convinced the threat was a mountain of fire. But what if the real monster has always been the water? Down in the comments, let me know what you thought was the biggest threat at Yellowstone before watching this. Was it the super eruption or the earthquakes? New discoveries, made in just the last few years, have given us the clearest picture ever of the magma system deep below. And what they show is not what anyone expected. It rewrites everything we thought we knew. The story is changing faster than ever, and a lot of people who love these deep dives sometimes forget to subscribe. This is one story you are absolutely going to want to be here for as it unfolds. Hit that button and let's begin. For a generation, the image of Yellowstone's interior has been a simple, terrifying one. A colossal cavern of molten rock, a liquid lake of fire sloshing miles beneath the geysers, waiting for a crack in the ceiling to unleash an apocalypse. It is an image that has fueled countless disaster movies and sleepless nights. It is also completely wrong. The truth, as scientists now understand it, is far more complex, and in some ways, far more reassuring. The magma reservoir beneath Yellowstone is not a lake, it is a mush, a crystal mush. Think of it like a hot rocky sponge, a vast zone of mostly solid semi-molten rock, with liquid magma trapped in the pores between the crystals. It is not an open chamber. It is a solid structure, saturated with melt. For years, the best estimates, based on the way earthquake waves slowed down as they passed through this zone, suggested that this sponge was about 9% liquid. 9% melt fraction, a number high enough to be interesting, but nowhere near eruptible. For a volcano to truly mobilize, for that mush to become a flowing, eruptible body of magma. Most models show you need a melt fraction, somewhere between 40 and 50%. At 9%, Yellowstone was stable, barely even awake. Then came December 2nd, 2022, a study published in the journal Science by a team including Dr. Ross McGuire and Dr. Brandon Schmont, changed the number completely, using a revolutionary new technique called full waveform inversion. Powered by the supercomputing methods pioneered by the late Dr. Min Chen, they used the seismic signals from the region's constant small earthquakes to create a far higher resolution 3D map of the magma chamber. It was like switching from an old tube television to 8K. The picture became undeniably, shockingly clear, and the number was no longer 9%. It was 16 to 20%. Double what we thought. Suddenly, the amount of known liquid rock beneath the park had doubled. Headlines wrote themselves. The volcano was waking up. The chamber was filling. The pressure was building. But here is what the data actually said. In the words of Dr. Ross McGuire himself, we didn't see an increase in the amount of magma. We just saw a clearer picture of what was already there. Nothing had physically changed miles underground. The rock was always there. The melt was always there. It wasn't that the volcano was getting more dangerous. It was that our flashlights were finally getting bright enough to see the true size of the room we were in. 16 to 20% is a significant number. It confirms a massive, melt-rich body sits beneath the caldera. It is a number that keeps volcanologists focused. But it is still, critically, half of what is needed for an eruption. This discovery did not shorten the fuse. It just gave us the first accurate measurement of how long the fuse actually is. The volcano was not more active. It was just better mapped. The science had worked. The impossible picture became clear. But it also revealed an even more profound question. If all that melt was there, what was it doing, and where was it going? Knowing how much melt exists is one thing. Knowing where it's moving is something else entirely. For decades, the western side of the Yellowstone caldera was considered the most active and dangerous part of the system. It was the site of the most recent giant lava flows, some 70,000 years ago. It's where the ground has historically risen and fallen most dramatically, breathing with the magma system below. The focus of the scientific community and the anxiety of the public was firmly planted in the West. Then, January 2nd, 2025, the United States Geological Survey published a paper in Nature that quietly and decisively shifted the entire map. Lead author Dr. Ninfa Bennington and her team used a technique called magnetotelluric imaging, which measures natural electrical currents in the Earth to map out structures far deeper than traditional seismic waves can see. They were looking for the telltale signatures of rhyolite, the sticky, silica-rich, and highly explosive type of magma that fueled Yellowstone's past supereruptions. What they found was a ghost. The old magma storage area in the western caldera, the one everyone had been watching, was fading. The electrical signature of a large, interconnected melt body was weakening, suggesting the rock there was slowly cooling, solidifying, and crystallizing. The giant was going back to sleep. But in the northeast section of the caldera, a new signature was growing stronger. Deeper basaltic melts, rising from the Earth's mantle, appeared to be pooling and stalling at the base of the crust, heating the rock above them and creating a new focal point for rhyolitic melt generation. The magma chamber wasn't just sitting there, it was migrating, shifting its center of gravity from the west towards the northeast. It sounds like the opening scene of a disaster film. A subterranean river of magma, changing course, flowing toward a new, unknown destination beneath one of the most active volcanic systems on the planet. But geology does not operate on a cinematic timeline. This shift is not happening over months or years. It is the product of thousands of years of slow, inexorable processes. The cooling in the west is the final, fading echo of eruptions that happened before modern humans existed. The new heating in the northeast is the first whisper of a process that may not culminate for tens of thousands of years more. It is not magma running toward a weak spot. It is the geologic heartbeat of a continent, a process so slow it is almost indistinguishable from stillness. Does knowing that the magma is just a crystal mush and that its movement is happening over thousands of years make it feel more or less dangerous to you? It's a fundamental shift in perception. Let me know your thoughts in the comments below. So the system was bigger than we thought, and it was moving slower than we feared. But a new mystery had emerged. All that rising heat in the northeast had to create pressure. All that new melt had to be releasing immense quantities of gas. So where was it all going? The surface wasn't bulging in a way that accounted for it. The gas vents weren't releasing the volume of sulfur that volcanologists would expect. Something was happening in between. A missing piece of the puzzle, somewhere between the deep magma and the surface geysers. Finding it would require doing something that had never been done before in Yellowstone. It would require them to create their own earthquakes. You cannot set off explosions in a national park. It's a non-starter. So, to get a picture of the shallow crust, scientists needed a different tool. Something powerful enough to send vibrations miles deep, but controlled enough not to damage the pristine and fragile environment of the Yellowstone Plateau. They found their answer in a 53,000-pound custom-built truck. Its official name is a vibroseis truck, but the crews who operate it at the University of Texas at Dallas call it T-Rex. During the quiet of the 2020 pandemic lockdowns, when the park was empty, a team of researchers led by scientists from Rice University and the University of New Mexico drove this behemoth to a remote spot near the Continental Divide. And in the dead of night, they started shaking the ground. A massive steel plate under the truck's belly pressed down and began to vibrate, driving 220,000 newtons of force into the Earth's crust. A controlled, sustained seismic signal that radiated downwards. The researchers, including Dr. Brandon Schmant, who had worked on the 2022 melt fraction study, along with Rice University's Dr. Chenglong Duan, had deployed a dense network of thousands of seismometers across the park. They were listening for the echoes. They were trying to ping the top of the magma chamber. The data that came back was a mess. a noisy, scrambled, almost unusable collection of reflections. The energy seemed to scatter in every direction. It was what Dr. Dewan called noisy, challenging data. He confessed that their first impulse was that the experiment had failed. It looked like they had found nothing. But he remembered the words of his advisor, when you see noisy, challenging data, don't give up. So they didn't. They processed the signals again and again, applying advanced algorithms to filter out the noise and stack the faint, coherent echoes that were buried underneath. And slowly, an image began to emerge from the static. It was not the blurred, gradual transition they expected. It was a line, a sharp, brilliantly clear boundary, and it was shockingly shallow. Published in April 2025, their results showed a distinct layer, a cap on top of the Magma reservoir, located at a precise depth of 3.8 kilometers, just 2.4 miles beneath their feet. This wasn't just a general zone where solid rock turned to mush. It was a defined structural lid, rich in trapped gases and fluids, sitting right on top of the main magma body. They had not just heard the magma chamber, they had found its roof. This discovery was monumental. It provided a hard physical boundary that had only been theorized before. It gave them a specific depth, a specific location, and a specific structure. The engineering had been audacious, the science had been relentless, and it led to a conclusion that turned the entire Yellowstone doomsday narrative on its head. If you know someone who worries about Yellowstone, who's seen the headlines about the ticking time bomb, this is the part of the video you should share with them. It might help them understand the real science, not the clickbait. Go ahead and hit the like button and share it out, because what they discovered next is the most important part of this entire story. That sharp line at 3.8 kilometers wasn't just a lid, it was a leak. When the research team analyzed the properties of that magma cap, they found it had a porosity of about 14%. It wasn't a solid, impermeable seal like the lid on a pressure cooker. It was more like a hardened sponge, full of interconnected cracks and pathways. And through that porous cap, the magma chamber is constantly, actively, and efficiently bleeding. The immense pressure from the volatile gases, the water vapor, the carbon dioxide, the sulfur compounds that exsolve out of the molten rock as it rises, doesn't get trapped. It doesn't build up over thousands of years, waiting for a single catastrophic failure. Instead, that gas finds its way up through the 14% porosity of the cap rock, leaking steadily into the vast hydrothermal system that sits above it. This is the missing piece of the puzzle. This is where the pressure goes. Yellowstone's famous plumbing, its geysers, its hot springs, its fumaroles, isn't just a passive feature heated from below. It is an active, dynamic pressure release valve for the entire volcanic system. It is Yellowstone's safety valve. The discovery of this leaky, porous cap is arguably the strongest evidence yet that the volcano is, in fact, preventing itself from erupting. The system is designed to fail, but in small, manageable ways. The catastrophic buildup of pressure required for a supereruption is being constantly short-circuited by a million tiny leaks, venting that energy safely to the surface day after day, year after year. It reframes everything. The real story of Yellowstone isn't about pressure building toward an explosion. It's about pressure being safely released. So when we see an event like the hydrothermal explosion in Biscuit Basin in June of 2026, or the one in Norris Geyser Basin in April 2024, we are not seeing a prelude to a volcanic eruption. We are seeing the safety valve in action. The danger is not that the whole system will blow. The danger is being in the wrong place when one of the small localized vents decides to unclog itself. And if you're thinking, wow, I didn't know the volcano was basically saving itself, then you're starting to see why we do this. I know this might be the second time I'm asking, but if you're getting genuine value from this and understanding this complex place in a new way, please consider subscribing. It really is the only way we get to keep making these deep dives into stories the mainstream news just skims over. It's important. The discovery of the safety valve was a paradigm shift. It suggested a level of stability that few had dared to imagine. But just as the picture of the plumbing came into focus, another team of scientists, halfway around the world, was about to complicate the picture of the engine itself. just when we thought we understood the volcano, the entire foundation it sits on was called into question. For half a century, the textbook explanation for Yellowstone has been simple: the mantle plume theory. A relatively straight, narrow column of hot rock rising from deep within the Earth's mantle, perhaps even from the core mantle boundary, acting like a blowtorch aimed at the underside of the North American continent. The tectonic plate drifts slowly southwest over this fixed hotspot, and the plume punches a new volcano through the crust every few million years, leaving a trail of dead calderas behind it like a string of pearls. It's a clean, elegant model, and it may also be wrong, or at least incomplete. In April of 2026, researchers from the Chinese Academy of Sciences published a stunning new 3D geodynamic model. They fed decades of seismic data, geological surveys, and geochemical analysis into a supercomputer and asked it to model the flow of the entire upper mantle beneath North America. The picture that emerged wasn't a simple blowtorch. It was a wind, a mantle wind. Their model showed that the immense heat source fueling Yellowstone isn't just a vertical plume. Instead, it's a vast, sweeping current of hot mantle material flowing eastward, deflected and channeled by the remnants of an ancient, sunken tectonic plate. This mantle wind scrapes along the bottom of the North American plate, pushing hot, buoyant rock up closer to the surface wherever the crust is thin or weak. Yellowstone, their model argues, sits at a point where this continental scale current is forced upwards, creating the massive thermal anomaly we see today. This doesn't mean the volcano is more or less dangerous, but it completely changes our understanding of its origins and its longevity. It suggests Yellowstone isn't just an isolated feature. It is a surface expression of a vast, continent-spanning geological weather system, a process tied to the motion of the entire plate and the deep structure of the Earth itself. It adds another layer of profound complexity to a system we are only just beginning to truly see. All of this, the crystal mush, the magma cap, the mantle wind, was made visible by advances in computational seismology, the ability to turn the faint rumbles of the Earth into a high-definition image. And that entire field owes a debt to pioneers like Dr. Min Chen, a computational seismologist at Michigan State, whose career was dedicated to developing the very supercomputing techniques that made these recent discoveries possible. Her work, before her untimely passing in 2020, helped build the tools that are now allowing a new generation of scientists to finally see the monster in its lair. And in seeing it, they are finding that it behaves in ways we never predicted. Take, for example, the mystery of the missing gas. For years, volcanologists were puzzled by Yellowstone. For a system with so much magma, it releases almost no sulfur dioxide, one of the key warning gases volcanologists look for. The levels are mysteriously, persistently low. A recent discovery finally explained why. The sulfur dioxide is being chemically scrubbed before it ever reaches the surface. As the gas rises from the magma and hits Yellowstone's massive groundwater system, it undergoes a chemical conversion, turning into hydrogen sulfide and dissolved sulfate. It's still there, but it's hidden, its signature masked by the overwhelming presence of water. Another secret, kept by a system that is far more intricate than we ever gave it credit for. So, the video title asks a provocative question. Yellowstone's magma pocket has shifted. Scientists say the clock has started. Is that true? Based on everything we now know, the answer is a definitive no. Not for the super eruption that haunts the public imagination. The clock has not started. In fact, the discovery of the porous magma cap, the system's own pressure release valve, suggests the clock may never start, at least not in any time frame that is meaningful to human civilization. The system appears to be fundamentally stable, engineered by nature itself to prevent the very catastrophe we fear most. The shifting of the magma focus to the northeast is a process playing out on a geological stage, over a span of time so vast it defies human comprehension. It is a sign of long-term evolution, not imminent crisis. The doubling of the melt fraction was not a new injection of magma, but a clarification of our own vision. We simply got a better look at what was always there. But this does not mean there is no clock, and it does not mean there is no danger. The clock that has started is the one for our understanding. Each of these discoveries has shattered a long-held assumption and replaced it with a more complex, more nuanced reality. We are in a race to map a system that is revealing itself to be more intricate with every new piece of data. And the immediate threat hasn't gone anywhere. The true danger at Yellowstone, today, tomorrow, and next year, is not from magma. It is from water. It is the hydrothermal explosions, the steam-driven blasts that can occur with little to no warning. As the June 2026 event at Biscuit Basin proved, the ground can still rip open. A 61-foot fissure of boiling water is a catastrophe for anyone standing near it, regardless of the melt fraction 2.4 miles below. The largest hydrothermal explosion crater in the park, Mary Bay, is nearly 2 miles across. A reminder that steam can be as destructive as lava, just on a more local scale. The work of scientists like Michael Polland, the scientist in charge of the Yellowstone Volcano Observatory, and Dr. Jamie Farrell, the chief seismologist, is a constant battle against myth. Their job is to track the 1,500 to 2,500 earthquakes that shake the region every year and to distinguish the normal hum of the volcano from a true signal of change. They watch the ground rise and fall. They monitor the gas. But their biggest job is often communicating that the real science tells a story of stability, not of impending doom. For over a century, we stood on the surface of Yellowstone, looking at the geysers and listening to the rumbles, terrified of the fire we imagine below. Now, for the first time, we have a clear picture of the beast. We see its true size. We see its structure. We see the safety valve that keeps it breathing. And the real question